Right, so this, we just took our test. This next section is section 5.6, which is on graphing linear inequalities. And the reason why I kept this separate from the rest of the chapter is because it leads into chapter 6, actually, where we do systems of inequalities. So when we graph a linear inequality, that's going to have less than or equal to, greater than or equal to. We're going to graph it very similarly to how we graphed equations, y equals mx plus b. So let's start with a very simple inequality. If we want to graph y is less than or equal to 2x minus 3. Well, we're going to graph actually the related function. So instead of less than or equal to, kind of pretend there's an equal sign there. And so the function we want to graph is y equals 2x minus 3. If you remember, minus 3, this negative 3 here, is the y-intercept. So we're going to go down on the y-axis to negative 3. And the 2 is our slope. So we're going to go up to right 1, up to right 1. Or you can even go down to left 1 if you really want. Once you get that, we're going to graph this using a ruler. And I don't have one, but you should have one. So there's our line. This would be the equation y equals 2x minus 3. But I want to graph now y is less than or equal to 2x minus 3. Well, less than means smaller than, and y, if you remember, is up and down. So we want to shade where y is smaller than this line. Well, that would be actually below this. So if it says less than or equal to, we're going to shade below. So I don't want you to think to the left, because if you notice this is actually to the right, but it is below the line. So this entire shaded region would represent the solution. We call this the solution set, this shaded region. That will be important coming up soon. But for now, you just need to know how to graph a function. So there are a couple nuances to this. First of all, if you have a less than or equal to, or a greater than or equal to, we're going to use a solid line when we draw our graph. If we have a less than or a greater than, we're going to use a dashed line, which means that we can't actually be on the line, but it's the boundary. And so, say that I wanted to graph the region y is greater than negative x plus 5. So this is what I want to graph. Well, I'm going to treat it kind of like y equals negative x plus 5, which has a y-intercept of 5. 1, 2, 3, 4, 5. A slope of negative 1, so go down 1, right 1, down 1, right 1. But instead of when I use the ruler, instead of just using a solid line through here, because this is greater than, I'm going to use a dashed line to represent that it can't actually be on the line, but it's going to be our boundary for the shaded region. So now I have to pick which side to shade on. Well, greater than means bigger than, and y again is up and down, so bigger would be up higher. So we're going to shade above the line. If the above and below confuses you, there's another way to determine what side to shade on, and it's called doing a test point. I usually will try 0, 0 as a test point because it is very easy to plug in. If I plug in 0, 0 here, I get 0 is greater than negative 0 plus 5. Well, negative 0 is just 0, so this says 0 is greater than 5. Hopefully you're like, that doesn't make any sense. 0 is not greater than 5. So because this is false, it's not true, we don't want to shade on the side of 0, 0. We want to shade on the other side. So if it's false, do not shade on the side where 0, 0 is, shade on the other side. Going back to the previous example, I could have done the same thing here. If I plugged in 0, I would have 0, 0, I get 0 is less than or equal to 2 times 0 minus 3, which says 0 is less than or equal to 0 minus 3. 0 minus 3 is negative 3. Well, 0 is not less than negative 3, nor is it equal to negative 3. So because this is false, you do not want to shade where 0, 0 is. Shade on the other side. So you can choose what method works best for you. I do not require that you do this, but I know for some people the whole up, below, above, below thing confuses them. Okay, so now I gave you all examples where y was already solved for. You're not going to have every single problem nicely solved for. So for example, you might have a problem where it looks like this. 5x minus 2y is less than 10. 5x minus 2y is less than 10. So in order to graph this, we need to solve for y. We need to get it looking like y equals mx plus b. In order to solve for y, I need to get rid of this 5x. So subtracting 5x from both sides, we're left with negative 2y on the left-hand side is less than negative 5x plus 10. I usually put the x first. Now we're going to divide by negative 2. But hopefully you guys remember from this part we just did, when we divide by a negative number, we know that this sign less than must switch to greater than. Negative 5 over negative 2, I'm going to leave that as positive 5 over 2. No need to make this a decimal. It's easy to do rise over run with a fraction. Positive 10 over negative 2 is minus 5. So now we need to graph the equation y equals 5x over 2 minus 5, which has a y-intercept of negative 5, a slope of 5 halves, so I'm going to go up 5, right 2. Up 5, right 2. And so forth. Now, because this is greater than, hopefully you guys remember the question should be solid line, dotted line. Because there's no equal under here, we're going to use a dotted or a dashed line. And now we need to figure out which side to shade on. Greater than means bigger than, so we're going to shade above. If you don't like that notation, or sorry, not notation, but phrase, then you can plug in 0, 0. You would get 0 is greater than 0 minus 5. 0 is greater than negative 5. This is true. Because it's true, you would want to shade on the side that has 0, 0. So that's this side. Okay, so the last thing that I want to cover for you guys is types of functions that are very simple but trip people up. So if I want to graph the equation x is greater than or equal to 5, well, there is no y equals mx plus b. There's no y in sight. But if you remember from last semester, whenever we had x equals a number, this was a special type of line. This is actually a vertical line. So we would go to where x equals 5, and we're going to make a vertical line at x equals 5. Because this is greater than or equal to, we're going to put a solid line. Now notice how this gets rid of the whole above or below question. We can't go above or below. So now we have to just consider x by itself. Well, where is x greater than or equal to 5? Numbers like 6, 7, 8, 9. So guess what side we're going to shade? The right-hand side. If you get a vertical line, then you want to think left-right. It may not be given to you like this. So what I mean by that is you may have an equation that looks like this. You may get 2y plus x is greater than or equal to 2y plus 5. And you'd have to solve for y. Well, when you try putting y on the same side, if you subtract 2y, those cancel, and you're left with this. So some of your homework problems you'll have to solve, but you'll notice one of the variables goes away. That's when you get this type of situation. Well, now, what if it's a y inequality? So for instance, y is less than -2. Well, again, if you remember to last semester, y equals a number is a horizontal line. So we're going to go to where y is -2, which is down here, and we're going to have a horizontal line at -2. But because this is less than, remember that less than means we want a dotted line or a dashed line. So we're going to put a dashed dotted line here, and then you need to decide what side to shade on. Well, y is less than -2. Numbers that are smaller than -2 are numbers like -3, -4. So here we're going to shade below. So our less than below fits in with the y. And again, this may not be given to you directly. You may have to solve in order to figure that out. So for your homework problems, I actually want to go through a few guided problems with you. If you feel like you have this, you can stop watching and maybe come back if you're a little bit lost. But again, I'm going to go through a few more examples and a summary. So just to summarize, less than or greater than, we're going to use a dotted line. Or dashed, same thing. Less than or equal to or greater than or equal to, we're going to use a solid line. If you have to shade with less than or equal to, in general you want to think to shade below. Unless or otherwise you're going to use a test point, like such as 0, 0. You don't have to do that, but it may help you. If you're going to use greater than or equal to, you want to shade above. And again, you can do the test point if this confuses you. Then, the other special cases, if you have x and then either less than or equal to or greater than or equal to, we don't know what's in this box, but a number, this is going to be a vertical line. If you get y, and then again, we don't know what symbol is here. It could be less than, it could be greater than, it could be less than or equal to, greater than or equal to a number. We're going to get a horizontal line. So this is what you would need to do. But in order to get to the graphing part, you first need to solve. So I'll do two more examples. First of which will be 2x plus 3y is greater than or equal to 18. So in this, the first step is to solve for y. To solve for y, we need to subtract 2x. So 3y is greater than or equal to -2x plus 18. Now we need to divide both sides by 3. And so y is greater than or equal to -2/3 x. 18 divided by 3 is 6. So now we're at the point where we could graph this. This is the y-intercept. and negative 2/3 is the slope. So we would end up going to up to 6 and then go down 2 and right 3. So I'm going to actually go to one of our graphs. So up to 6, which is right here, then go down 2, right 3, that's down 2/3, so down 2, right 3. And then because this is greater than or equal to, remember the equal to underneath means we want to use a solid line. Then we would want to figure out which side to shade. Greater than or equal to means bigger than, so we're going to shade above. Or if you don't like thinking about that, if it confuses you, then you could do a test point. 0 is greater than or equal to, oops, I forgot my x, 6. 0 is not greater than or equal to 6. So because this is false, we don't want to shade where 0, 0 is. We want to shade the other side. Okay, doing another problem, and this time I'll stay on the same page. If we have the problem negative 2x plus 6 is greater than 12. We want to solve, but notice how there's no y anywhere. So we're just going to solve for x. Subtracting 6 from both sides, negative 2x is greater than 6. Now we want to divide both sides by negative 2, but remember, dividing by a negative means to flip that sign. So we have x is less than negative 3. Well, remember, if we have x, a symbol, and then a number, this is going to be a vertical line. But because this is just less than, we don't want to use a solid line, we want to use a dashed line. And so less than means smaller than. Well, numbers smaller than x appear to the left. And so we're going to shade this side. And again, if we have an x and a number, this is the only time that you want to think left, right. Otherwise, you want to think above and below. So it's kind of a special case. So now you'll have your homework, and I'll send you guys an email to update you as far as class goes for tomorrow.